Hi guys. Okay, so today we're going to look at finding rational roots of polynomial functions and the rational root theorem. So the first part is the rational root theorem. This says that if p of x is a polynomial with integral coefficients, that means no fractions, no decimals as coefficients, then p over q is a rational root of p of x if and only if P and Q are relatively prime. Relatively prime means that the only number that goes into P and Q is 1, okay? And here's the key, P over Q equals factors of the constant term over factors of the leading coefficient, okay? So let's take a look at this. Here's an example. A p of x equals x cubed minus x squared minus 10x minus 8. Now, the first thing I'm going to ask you is how many roots does this have? This is a third degree polynomial or cubic, which means it's going to have 3 roots. Now, if we're going to list all the possible rational roots, we're going to take the factors of the constant term, which in this case is the negative 8, over the factors of the leading coefficient, which is the invisible 1. And I'll tell you, we love when the leading coefficient is 1. It makes it easier because the factors of 8 are a positive and negative 1, positive negative 2 go into 8, a positive and a negative 4 go into 8, and so do both a positive and a negative 8. And the only numbers that go into 1 are positive and negative 1. Now, we have to divide every number in the top by every number in the bottom. And we like this because when we divide by 1, we just get the top. So our possible rational roots are plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. That means there are only 2, 4, 6, 8 possible rational roots. So if you look at the graph, you can see where it crosses. If it crosses at an integer, it's going to be either positive or negative, 1, 2, 4, or 8. Those are the only integers we could have. And notice there will be no fraction roots. Not a half, not a third, not 5/8, no fractions. So if it's crossing in between integers, that means you have an irrational root. Now, we're going to use C polyroots to find the actual root. So I'm going to come over here to my TI Inspire. And to use C polyroots, we do Menu, Algebra, Polynomial Tools, and number 3, Complex Polynomial Tools, Roots. So we're going to type in our polynomial, which is x raised to the third, get out of my exponent, minus x squared, minus 10x, minus 8, comma, remember the comma's over here next to the O, and we have to tell it what variable we're using, and we're using variable x, and we hit enter. So we have all 3 roots. We know what the roots are. So the first problem I picked is I picked one where we already know the roots. We know that the roots are x is going to be negative 2, negative 1, and 4. Okay, now you can pick any one of these roots to start with. It's totally up to you. I'm going to pick the first one, negative 2. And I'm going to use that root, and I'm going to do synthetic division. So I had 1x cubed, negative 1x squared, negative 10x's, and my constant is negative 8. Now remember, these are the coefficients on my cubic, okay? And I'm going to do synthetic division, and I bring down the 1. Negative 2 times 1 is negative 2. I add these, I get negative 3. Negative 2 times negative 3 is 6. I add those, I get negative 4. Negative 2 times negative 4 is 8. I add them, I get 0. If I didn't get 0, something is not right because we knew this had to be a root, which means it has to go in evenly. Now we have the coefficients on our quadratic. Now, if we look at this, if negative 2 is a root, one of the factors is x plus 2. And then we have here the coefficients on our quadratic would be x squared minus a 3x minus a 4. But you know what? I bet we could factor that again because we know how to factor quadratics. I'm going to keep my x plus 2. I'm going to use 2 parentheses. What multiplies to negative 4 and adds to a negative 3? That would be a negative 4 and a positive 1. So now we've already found now p of x as a product of linear factors. We managed to factor it already. And we're ready to find all our roots. The root of x plus 2 is negative 2. The root of x minus 4 is 4. And the root of x plus 1 is negative 1. We have all three roots, and you can write it this way, or you can write it in the set notation like we had before. So the key is we're using the C-poly roots to get us started, and we do synthetic division until we get to a quadratic because we know how to handle quadratics. If it's something we can factor, we factor. But sometimes we can't always factor. Let's look at a simple one that we can't necessarily factor. Okay, so let's do one more. Here, f of x is 2x to the fourth minus x cubed plus 7x squared minus 4x minus 4. How many roots does this have? Well, the highest power of x is 4, which means this has 4 roots. All the possible rational roots, this would be the factors of our constant term, negative 4, over the factors of our leading coefficient, which is 2. Now, the factors of negative 4 would be plus and minus 1, plus and minus 2, and plus and minus 4. Factors of 2 would be positive and negative 1, and positive and negative 2. Now we need to divide everything in the top by the bottom. So I'm going to start. 1 divided by 1 is 1. 2 divided by 1 is 2. And 4 divided by 1 is 4. Now I'm going to divide everything in the top by the 2. 1 divided by 2 is 1/2. 2 divided by 2 is 1, but I have that already. And 4 divided by 2 is 2. I have that also. So here are my possible rational roots. Notice again, 2, 4, 6, 8 possible roots, rational roots, and the only fractions we can have are 1/2 and negative 1/2. Okay? So now we're going to go back and we're going to use C-poly roots. So we're going back to our calculator. We're going to do menu, algebra, polynomial tools, complex roots of a polynomial. And we're going to type in our polynomial, which is 2x raised to the fourth, get out of our exponent, minus x raised to the third, get out of your exponent, plus 7x squared, minus 4x, minus 4, comma, next to the O, and then we tell it the variable is x. And we hit enter. Now notice we have some weird looking roots there. We do have a fraction of negative 1/2. We do have an integer at 1. And then we have two imaginary roots, negative 2i and positive 2i. So let's write down what our roots are. So we already know the roots. We know our final answer. We have negative 1/2. We have negative 2i. We have positive 2i. And we have 1. We're going to take one of the rational roots. Your call whether we take negative 1/2 or 1. It's up to you when you're doing this. I'm going to take the negative 1/2 first. And I know most of you are probably going to take the 1, but I'm going to break you of it. So here we go. We're going to take our coefficients of our quartic. We have 2x to the fourths. We have negative 1x cubes. We have 7x squareds. We have negative 4x's. And we have a constant of negative 4. And these are the coefficients on our quartic. Okay? And we're going to do synthetic division. We bring down the 2. Negative 1/2 times 2 is negative 1. Add those up. Negative 1 and negative 1 is negative 2. Negative 1/2 times negative 2 is a positive 1. Now we add. 7 plus 1 is 8. Multiply negative 1/2 times 8. We're going to get negative 4. Add them up. Negative 4 plus negative 4 is negative 8. Now we multiply. Negative 1/2 times negative 8 is 4. Add them up. Negative 4 plus 4 is 0. These are the coefficients on our cubic. Now we're usually not so good at factoring cubics either. So we're going to do synthetic division again on these answers. Okay, on those answers. So I'm not even going to rewrite them. We've already used the negative 1/2 root. So we're going to use the other rational root, 1. And we're going to draw this here. We're going to bring down the 2. 1 times 2 is 2. If we add negative 2 and 2, we get 0. 1 times 0 is 0. If we add them, 8 and 0 is 8. 1 times 8 is 8. Add them and we get 0. Remember, if we don't get a remainder of 0, it means we did something wrong. Either we have the wrong root or our arithmetic is wrong in our synthetic division. So if we had a cubic and we did synthetic division, we now have a quadratic. Quadratics we know how to handle. This is 2x squared plus no x's plus 8. So I'm going to take this 2x squared plus 8, and I'm going to set it equal to 0. It's up to you how you want to factor this. You could factor it, or you could do the quadratic formula, or on this one, it's not so bad if you just subtract the 8, divide by 2, and x squared is negative 4. Now, if you take the square root of both sides, what's the square root of negative 4? Well, it's 2i, but it's also negative 2i. So there's your last two roots. We now have the roots. We had negative 1/2, we have 1, and we have positive and negative 2i. I am perfectly okay if you write it this way instead of this way with all four separated, as long as you realize that is indeed 4 roots. Now we have to factor this. The name of our polynomial here is f of x. If negative 1/2 is a root, do not write x plus 1/2. That denominator 2, remember, has to come up. So it's 2x plus 1. If 1 is a root, it's x minus 1. Now here's the thing. We don't usually use linear factors when we have imaginary or complex roots. Usually, we would go back here where this 2x squared plus 8 was. We would factor out the 2 and have x squared plus 4. Okay, and I'm going to put that 2 up front, x squared plus 4. And this is usually how we would factor it. It is also possible to have 2x plus 1 times x minus 1 times x minus 2i times x plus 2i. But we don't usually see that notation. Okay, guys, we're going to do more of this in class. We'll talk to you soon. Bye.